Everyone, welcome back to Tech Junior Tutorials. My name is Lee Work Jr. and we're doing Advent of Code, and today is day 9. So let's check out this puzzle. So we are back to the int code computer again. They say that this is the, I hope they're indicating this is the last day that we use this thing because it's getting kind of out of hand at this point. But anyway, we have to refactor it to add in some modes. So if you're not familiar with the int code computer, that's days 2, 5, and 7. So whenever they say existing int code, they link you back to day 5. And you don't actually need any of the stuff from day 7. So if your if your day 5 solution is good, then you should be fine here. So what they have you add in now is a mode 2. So for review, mode 0 and 1 are immediate and position mode, meaning when you get a parameter in, so we got some inputs down here. So like this 109, this 1 in front, like the first 2 digits, that's the code, that's what operation to do. And then the 1 tells you that it is in, I think, immediate mode. So that means you're going to, instead of looking for whatever the value is at position 1, you're just going to use 1. But now we're going to do relative mode. And basically what that says is that you're going to have some number that you're keeping track of while you're running the program. And your index, instead of being, like here is a value in relative mode, instead of being a -1, it's going to be index -1 plus whatever the relative mode value is. So if it's like 10, your new value would be 9, so you would output whatever's at position 9 in that case. So they tell you that, and then they give you a couple test cases, thankfully, again. Although these weren't as helpful as some previous days because there's some tricks in there. Particularly when you are dealing with the third parameter and inputs. So before, inputs didn't care about like relative mode or immediate mode or whatever. It was like whatever the value was. So if this was a 3, it would just say like, you just get an input and store it at that address or that index. Now you have to worry about relative mode. But it's a little bit different. Because instead of looking up the value, like you would do with these two, you are not going to look up a value, you're just going to compute the relative plus that index, or that immediate value. So it's kind of like the opposite of these other params. So like here, you got a 1 that tells you addition, this says look up, and then immediate. So like what that means is this first parameter, it's going to be whatever's at position 100. And then for the second one, it's the immediate value, so 1, not position 1. But with the right, it is opposite of that. So here, we're supposed to basically take those previous two here we're supposed to take those previous 2 values, because an addition takes 3 parameters, like the things to add, and then where to write the answer. So here, remember, we had to like look up what the value was at position 100. Here, it's like the index is 100. That's where you're going to write the answer. But this can now run in relative mode, meaning you need to, if it's, the mode is 2 or relative, you need to add that to the relative base or whatever it is. So you're not doing a lookup basically for that third parameter, which throws things off a little bit. It did for me, certainly. So jumping to my code real quick, I didn't really change a whole lot for my int code program, so a lot of that is the same. They tell you that now you have an opcode of 9. So I have a relative base, which all the way at the top, it tells you to start at 0. It also tells you that your program should be like way bigger in memory, and that any addresses that aren't there should be 0. So instead of like dynamically adding indexes whenever I was doing a lookup, I just added 10,000 zeros to the end of the program to be lazy and just hoped that that was big enough. And it seemed to work out, so I got lucky. Certainly, I think I tried to do the dynamic expansion of the program at first, but it didn't work. So I was like, let's just be lazy and add 10,000 zeros to the end of this list. So yeah, you start at back to the relative base thing. Start at 0, and then the new opcode 9 tells you that whatever that param 1 is, just add that to the relative base. So if it's a negative number, add it. If it'll subtract from the relative base. If it's a positive number, it'll add it to it. So you can handle that just by adding whatever that param is to the relative base, and then jumping ahead 2 places. So aside from that, adding the zeros, adding the new opcode, also had to refactor my code for determining modes. So before I was doing like a ternary here that just said like if the mode's 0, do this. If the mode's 1, do this. But now I've got a handle mode function that I built in. So that is at the top here. But this, as I wrote this, this only works for params 1 and 2 if you are doing like addition and multiplication. But if you're doing like a param 3 where you're looking for the output, or if you're doing param 3 where you're looking for where to write the input, or I'm sorry, that's opcode. Param 3, if you're doing addition and multiplication, would be where you're going to write to. If you get an input, so opcode 3, that's where you're going to write the input to, or opcode 4, where you're supposed to output from. All those aren't going to work for this formula because I'm doing that lookup here on relative mode. So instead of like refactoring this to say like, oh, if it's this parameter, that parameter, or whatever, I just again decided to be lazy and kind of add in some stuff. So basically here, instead of doing the same function for parameter 3, I just say, hey, if I'm in relative mode, just add that base to the index. And then I had to, before I was just like saying, hey, if opcode is 3, just return that value. Don't even do any of this other fancy stuff. I had to get rid of that. And then parse opcode 3. And then also interesting, because now we are going to have to deal with that third position, whereas before it was always just give me the index and use that. Now it can give you that relative mode, so I needed to pad further my parameter modes. So before everything was like a 0 if it's not there. Now that third parameter should always be a 1 because it's going to say, hey, just give you the index, which is super confusing to think about. If you're not following along, I don't blame you. Basically, I don't think they even give you an example of that in here, but here where you're doing an addition problem, these first 2 numbers are what code to do, and then that's the first parameter, that's the second parameter, but there could be a third one before this 1, which could be a 2 now. And if it's not there, you would think it would be a 0, but the way that I wrote my logic, I would want a 1 to be there because I want that third value to be the index instead of do a lookup and give me the value at that index. So super confusing to think about. If that kind of blows your mind, don't worry, it did mine too. I had to refactor pretty heavily this morning to kind of wrap my code around that. I thought it would be a lot cleaner. But I do that padding for a code that's of a length 3, and then for a 4, and then if it's 5, I just reverse it, and it should work out just fine. And I got lucky there, and it did. So real quick, they tell you that you've got to handle like a much larger program, a whole lot more memory. You have to add in the relative mode, and once you get that running, they tell you at the very bottom here, your program's only going to ask for the value 1. So I just wrote a quick function to do that. So right there, get input 1, it just returns 1. So my program, whenever I hit an opcode 3, just calls that function. So they give you some test cases again. They're not as helpful, but they're pretty nice. So this first one, it tells you it should produce a copy of itself, and indeed it does. So I get the same outputs, just outputs everything in this array. This one is going to multiply these two big numbers together. So it's testing to see if your runtime can handle gigantic numbers. And then this last one, again, is just going to output this value. So the test cases don't test relative mode a whole lot, which isn't very helpful, especially because whenever you're dealing with those cases in relative mode, that's like where the beef of the challenge is. So basically, they tell you you're supposed to give it an input of 1, and it spits out at the end either what is malfunctioning with the parameter mode that's malfunctioning, or the actual answer. And it should, if you only get one thing, it should be the answer. So if we run that, we get this giant number. I'm not even going to take a crack at this one, but that happens to be the value that I was looking for. Part 2 today was a pleasant surprise. You see how short this is. It says, hey, if you pass part 1, that means your stuff works. Now just give it the value 2. That's it. So if you change this to 2 and hit save and run it, it takes a second, and then boom, it pops out a new answer, which is the coordinates of where Santa's at. Or actually the distress signal, I guess. So I guess it does a lot of math behind the scenes. There's a huge amount of input here. I don't know if you can tell, but there's a lot of stuff in there. I don't know what it does, but basically, yeah, that's all there is to part 2. Just let it run, and it should be a little bit harder of a calculation for your processor, which they say in here. It may take a few seconds on slower hardware. So I guess I have slower hardware because it took like 2 seconds to pop out. But yeah, that's it for day 9, which was a like a good thing and a bad thing. Bad because I didn't want to work with Encode again. I'm kind of tired of that at this point. All the refactors and stuff are kind of getting crazy. It was good at day 5 to get it going. Day 7, where you're doing all the amplifiers and stuff, not a huge fan of that one. The instructions were kind of rough, and it required a lot of like weird refactors to the Encode program. Today's again just adding some extra weird logic to it, and then it just runs. But it was good for part 2 because you just had to change the value to 2 from 1, and then boom, you get your answer. So that was awesome. Looking forward to day 10. Hopefully we get something aside from Encode, and it's an interesting problem. But yeah, that's all I've got. See you tomorrow. Bye.